Okay, let's continue. Okay, thanks for coming. So today we'll be talking about Internet Protocol deep dive. So previously we were talking about technology, so it's more hands-on. Click here, click there. But today we'll be talking about one topic here that requires, yeah, perhaps some analytical level in order to understand the technologies that is called Internet Protocol. Okay, so my name is Achmad Mardiansyah and I'm from GLC Networks Indonesia. So this is the agenda. I will be talking about introduction, review, Internet Protocol, some troubleshooting, and then yeah, with this troubleshooting we can do some practice how we troubleshoot an issue in layer 3. Okay, for introductions, we are GLC Networks. We're based in Bandung, Indonesia. Our areas are training in IT consulting. So these are the some pictures of our past events. Okay. Yeah, we are doing Macrotik, Ubiquiti, Linux, and then some programming. My name is Achmad. I'm based in Indonesia, in Bandung. I use many technologies, including Linux, Macrotik, and etc. etc. I have a LinkedIn account, so if you have same account in the same platform, you have account in the same platform, perhaps we can connect. Okay. So past experience, we do, yeah, as I said, networking, sysadmin, and programming. Yeah, so those three things. Usually, my clients are from ISP, so they have network, and then I work with them to do something on their network, either to upgrade, to integrate, and yeah, things like that. Okay, about the webinar itself, thank you very much for you guys. Some of you already joined in our webinar as a presenter. Yeah, really thank you for that. So I really encourage for those who haven't joined, please join. Okay, and then we will schedule a slot for you. Okay, perhaps you can share something to community. Okay, so yeah, yeah, sharing experience. I don't think so. It's not like when you have a thing, physical things, when you give it to somebody and then those physical things is gone. Yeah, because you are moving from one to the others. But if you are sharing an ideas, and then others also sharing the ideas, and then you will have more ideas. Okay, so don't be afraid about your ideas if you are doing a presentation here in our webinar. Okay, so if you want to do a presentation, just let me know. Okay, for those who join, please inform where you are from. Okay, at least we know where you are from. Okay, so usually there are people from Asia, Europe, and Africa. So please introduce yourself here in the group chat. Prerequisite, yeah, well, even though this is the topic is IP protocol deep dive, but yeah, yeah, at least you need to have some basic. At least you know what the IP protocol is, and then at least you must have some experience with the a device that is related to the IP protocol, especially the network. Okay, so let's get started. So we know that in our communication, we have a concept of layers. So each layer has its own functions, and then each function is depicted by a protocol. So one layer consists of many protocols. So it depends on us which protocol we want to use. Okay, it depends on the application as well, right? So usually this is the things that we are aware of. Yeah, like a web server, okay, NFS server for sharing files, NTP for sharing the network time, FTP for data transfer, file transfer. DNS is also important. SIP, see, SIP is for having a communication, a voice call or video call. Yeah. So based on that, each application has its own way for communication. Okay. And then if we are sending to the network, and then there will be a process for encapsulation. So it means that the data here from upper layer here, okay, will be sent through other layers, and then during the process, the computer will add more information in the form of header. Okay, so the encapsulation process, I think you already know. So this is the encapsulation process from top to bottom. Okay, if you want to send, and then here is the process, and then here is the every process has its own way for naming the results. If it is layer 4, this is layer 4. If it is TCP, we call it segment. If it is UDP, we call it datagram. On layer 3 here, we call it packets. Okay, and then when we send through the data to the physical hardware, okay, we call it frame. Yeah. So this one we already understand. Perhaps if you are studying in the computer science, in the network, usually you will study this kind of things. Okay, if we take a look, so here we already know that, oh, okay, there will be a header here. Okay, if we zoom in, okay, if we zoom in, and then this is how it looks like. Okay, layer 4 header. Okay, so we have a source port and so on and so forth. We don't talk about this much. Okay, perhaps in the future session we will focusing on layer 4. Okay, this is layer 3. Okay, our favorite layer tonight. Layer 3 has 2 versions. This is V4 and this is V6, yeah, version 6. Okay. Okay, in this webinar we will be talking about what are the meaning of these things. Okay. And then we have layer 2. Yeah, layer 2 if you use the Ethernet, and then layer 2 header if you use Wi-Fi. So this is, for recap, is the encapsulation process. Okay, one block here, one box here means 1 byte. Okay, so this is 1 byte. So you can imagine this is the total bytes you send in your WhatsApp or whatever, and then this is actually what the computer sent. Yeah, so lots of lot of things. Yeah, not only your original message, but yeah, other things as well. Okay, so IP spec, yeah, IP specification, not IPsec. Okay, so it's different thing. So the specification of IP is defined in 1981, long time ago. Yeah, 40 years. Yeah, 40 years, right? Yes. Yeah, 40 years ago, man. Yeah, so this is the oldest technology in our communication so far. Yeah, still being used up to now. Okay, so yeah, this is how we use our technology. Okay, so one of the oldest technologies still exists today. Okay, so let me share another window. Yeah, so if you Google, can you see my screen? Yeah, so if you Google IPRFC, and then you can see here the internet protocols. Okay, internet protocol specification, blah blah blah. The overview, here's the motivation. Okay, you can read it yourself. But yeah, this is how the internet protocol, see, stack with the other protocols. So at the lower layer, we use internet protocols. On top of that, we can use other protocols like either TCP or UDP. Okay, so the model of operation, yeah, is like this. Okay, so application program, internet modules, and then they send it to the local networks, and then so so this is how they there is no Microsoft Word at that time, 1981. Can you imagine that? They only have a typewriter. Okay, but it doesn't mean they don't have their own creativity. Yeah. So as you can see here, here's our application, for example, Telnet or whatever. Yeah. Telnet at that time was very famous. Okay. So from host A to host B. Yeah. So it sends through one network here, and then the message will be forwarded to the other device, okay, and then send it to the different network. So you can see here, network 1, network 2, and then arrive to destination, okay. So yeah, function description. Yeah, so this is the purpose of uh, internet protocol. So the first function is for addressing, okay, here, okay. So yeah, so here it is said that, okay, the address is a fixed length, only 32 bits, yeah, yeah, which will be divided into two parts, the network part and the host part, okay. Also, there is a possibility, so here are still talking about the function, okay. The next function is for the fragmentation, yeah. So for example, fragmentation means, so for example, this is a router, okay, and then this is another router, okay. Yeah, there is a possibility that the technology here is different than this technology. So this is layer 2, this is another layer 2, okay, and this is layer 3, this is layer 3 device, right? Layer 3 device, okay. So this one is very old technology. Only so if you use the encapsulation process, the layer 2 here is very small. Only, for example, 700K. This one is sorry, 100 and 1,500 bytes. Yeah, and this one is only 700 bytes. Okay, only half. So what happened when when a frame? So remember the encapsulation process, right? So we have a frame here. The frame arrives here. Okay, the frame size is 1,500. Not the frame. Uh, well, actually, it's called MTU. Okay, let's switch the this one. Okay, yeah. So let's switch the oh, maybe not. Okay. So as you can see, so this is layer 2, yes. This is layer 2, okay. And then the content, the header of layer 2 is this one. Oh, this is also layer 2, yeah. So the content of layer 2 is from here to there. Okay, so from here to here, okay. Yeah, so this length is called MTU, okay, maximum transmission unit. Yeah, for Ethernet, MTU is 1500, but Ethernet is this one. Yeah, but in other stuff, maybe the MTU is only 800 bytes, yeah, in other technology. So this is where the function of fragmentation comes in. Okay, so let's switch back. This one, right? We're still talking about the IP protocol itself. Remember, today's topic is IP protocol deep dive. Yes, so we will discuss the function, wow, zoom more details about the internet protocol itself, how it is designed. Okay, so as you can see here, so if we have a 1500. And then on the other segments, we cannot say 1500. It cannot send a 1500 a packet. Yeah. So the way it does is doing the fragmentation here. Okay. So in the so this is a router. Okay. So before we only have one packet. Yeah, 1500. Okay. But here, the capacity, a layer 2 capacity is only 800. So it means we have to split this one into 800 and plus, so 500 plus 200 is 700. So the packet will become fragmented. Okay. Why? Because the layer 2 over here only allow 800 bytes. Okay, so that's why we do the fragmentation over here. Okay, so there is a flag called do not fragment for the tools. So it means that I don't want to do fragmentation on this. And then what will happen if we say do not fragment? It means that there will be an error from this router saying that, oh, okay, your packet cannot go through because you said do not fragment. So the option is to allow fragmentation, but from our side here, okay, from our browser or whatever, we can say that, okay, do not fragment. Yeah. Okay, so that's the second function for IP, Internet Protocol. Yeah, and then after it receives, there is a possibility to assemble the fragmented packets. Okay. Next thing is for gateways. Yeah. So as you can see, this is where the routers comes in. The purpose for this is the router, right? So the purpose for the router is to connect one network and to the other network. So this is the router. And then every interface of the router will have an IP address. Okay, and then a host here will use that IP address of the router that will be using IP address of the router as their gateway. Okay, so that they can reach from here to here. Okay, so that's the function. Okay, 2.3 was function. Okay, 2.4 was gateways. And then here's the Ethernet format. I mean, Internet header format. Yeah, so here the first 4 bits. So here is version. Okay, so only 4. So it says that, okay, the version is 4. Okay, and then IHL, internet header length, how long from here to here. Okay, so it says here. And then type of service, okay, like for example, here we can use, previously we use TOS type of service, but now they change it to the SCP. Yeah. So this is 8 bits. So saying that, oh, okay, so this is a high priority. We tell the router that, oh, okay, this traffic has to be uh, uh, real time. Okay, so please do not put into lower priority. Yeah, so we can tell the router so that, okay, this packet is on higher priority on this field. Okay, so next is total length. So this is also length, and this is also total length, but this is the length here is only the header length. Okay, the total length is for the total. Yeah, see, 16 bits. Okay, measured in octets. Yeah, see how many octets. So, and then we have identification. Okay, identification fields. Okay, 16 bits to for again for identify the fragment. Is there any fragmentation there? Okay. Next is flag. Okay. Only 3 bits. Okay. Either reserve must be 0, or here a don't fragment or more fragment. So yeah, that's how we reassemble the packets, the fragmented packets. So again, in the beginning, the total length of your packet is 1,500. After it receives routers, and then unfortunately the next layer 2 only 800. So you have to split 1,500 into 800 plus 700. Okay. So how the IP address do that? Using the flag here, identification and then flag. Okay. Next is time to leave. Okay. This is 8 bits. And then here's the upper protocol. So indicates that the upper protocol is something. Okay. So it depends on the assigned number. Okay. So we tell them, oh, okay, the upper layer is TCP or UDP. So as I said, this is IP protocol, right, on layer 3. And then on top of that, we have protocols, yes. And then we have to register the protocol here, either TCP or UDP, and so on and so forth, yeah, with this protocol information. Okay. Also, if you know about Quick, why do we use UDP for Quick? Actually, Quick is designed to be a new, so it doesn't follow format that is done, that was designed for TCP UDP. So Quick is newer protocol. Okay, but if we do that, and then we have to upgrade all firmware for all routers around the world, because we have. So here's the thing, right? We have to tell that the upper layer is either TCP, UDP, okay, and down, and then after several decades, okay, we tell them, oh, okay, let's invent a new layer 4. Okay, so we already have TCP, we have UDP. Okay, why don't we just create a new one? Okay, that's a good idea. But we have to inform that the lower layer, which is IP, Internet Protocol, to be aware that okay, there is a new protocol named Quick. Oh, okay. I don't know this one. For some router, it's okay, but for old router, for old firewall, they said, oh, okay, I don't understand this layer 4 protocol. I just dropped them. Oh, okay, we have problem. Yeah. Yeah, so that's the purpose of flag of the field protocols in IP spec. And then here is a header checksum to make sure that the header has no, error. If there is an error, and then we send them. Oh, okay, we don't. We will drop them, and then please send again. Okay, so header checksum. It's like MD5 to make sure that if you download something, okay, or a big files, usually there is a MD5 sum, right? For that. Oh, perhaps I can open the. Yeah. Okay, so here are the headers. Okay, version, internet header length, blah, blah, blah. Here's header checksum. So it's checking all of them. Okay, make sure there is no error in our header, layer 3 header. Okay. Yeah, because this is only, this is binary, right? Either 0 and 1, 0 and 1, 0, 0, 1, 1, 0, whatever. Yeah. So a checksum also do the job by, generate a checksum with some algorithm like MD5 or SHA1 or CRC procedure here. Okay, to make sure that okay, there is no error in our header. Right. Next field is a source address and then destination address. Okay. I think everyone is clear here. Okay. And then here's for options. Okay. Yeah, option for other purpose. Okay. These are for feature use and so on and so forth. And then we have a padding. Okay, if it is necessary. Also, source and then record route. Okay. Next, um, the internet protocol here also with the optional specification. They also provide several features, in their optional, like for example here unclassified related to security, handling restriction, transmission control code, source route, okay, to check whether the source IP address is really coming from the legitimate interface. Okay, so here for example, so we have a router here, okay, and then over here we have 192.168.1.0. okay. Yeah, so if packet coming from here, so this is, we have a destination address, we have a source address, right? So destination address, if the packet coming from this direction, destination address must be here. Okay, and source address must be from there, from that network, right? Yeah, but there is a possibility that the destination is somewhere, or maybe we have more than one. We have more than one, so 192, 172, 16.1.0, right? Yeah, so this router connected to two networks, okay? So for this packet, arriving at this interface, okay? So destination address is this one, but the source address is from this one, okay? This doesn't make sense. Okay, so again, we have three interfaces, yeah? Packets coming from here arrive at this interface, but the source address coming from here. It doesn't make sense. Okay, so the packet has to be coming from here. Yeah, so that's why we have a record route here to check whether the packet is coming from the appropriate interface or not. Okay, so hopefully everyone can can follow. Okay. Okay, so yeah, so that was the spec specification of internet protocols. Okay, started from version, internet header length, the TOS or QoS. Yeah, so this is how we provide QoS. Total length in newer definition, the TOS is now called DSCP. And then we have a total length, identification flag, fragment offset. Yeah, so yeah, so this one here is showing you that whether the packet is fragmented or not. Okay. Next is time to leave, protocol, header checksum, source address, destination address, and option here. Yeah, so we have lots of options. Okay. Yeah, and then if option is not being used or used for some extent, and then we can add here the padding, okay, to make sure that that the data is each row, yeah, so 1 2 3 4 5 1 2 3 4 5 6, okay, 6 row here has 32 bits. Okay, we start from 0 until bit 31 here. Okay, so that was it about the IP spec. Okay, so let's change the slide. Okay, so as you can see, there is a big overhead about encapsulation process. Okay, now let's talk about the IP addressing. So the one purpose for internet protocol is for addressing. Okay, so we have a layer 2 addressing, layer 2 addressing, layer 3 addressing. Okay, both has its own function. Okay, layer 3 is for end-to-end. This is our focus today. Okay, that was depicted by internet protocol over here. So this is our focus today. So we there is an addressing for layer 2. Yes, I know, but today our focus is on internet protocol. Okay, so every computer must have an address, and then that address has to be unique. In order to make sure that the uniqueness of the IP addressing, we need to have a body, a global body of in the level of the world scale that is managing the IP address, and then that body is called IANA, okay, Internet Assigned Number Authority. Okay, so that's the organization. Yeah, where do the organization? So this is not non-profit organization, yeah, but that organization must have money to run their organization. Yes, yeah. So from where the money from? Yeah, where the money from, so that they can use it to operate their organization, from the from the members. Okay, so IANA has a block of IP address, and then if we want to send data in the internet, we need to have an IP address. So we have to reserve an IP address from IANA. Okay, IANA is not alone. Okay, IANA delegates the addressing authority, yeah, to RIR, Regional Internet Registry. So in Asia Pacific here we have EPNIC. Okay, in Europe we have RIPE NCC. Okay, in Africa we have EFRINIC, Latin America LACNIC, North America we have ARIN. Okay, so we contact them to EPNIC. So I'm from Indonesia, so I just contact EPNIC. Their base is their headquarters is in Brisbane, Australia. So I'm telling them that I need an IP address. Can you do that? Okay. You have a /23, for example, and then here's the money you have to pay per year. Okay. Yeah. Done. /23, /24, /22. So you ask them if they still have reservations, reserve for that, and then they will give it to you as long as you pay. So there is no ownership here. What you have is just right for use. Okay. And then IPv4 is getting less and less. So yeah, there is no addressing. There is no addressing left. Yeah, as far as I know, for IPNIC. Yeah, for others, RIR, I don't know. Okay, so again, IP addressing has to be global and has to be unique. So this is how the address looks like. We know that in layer 3, we have 32 bits of IP address. So this is how we use, we put an IP address in binary format. But the way we configure our router or our network device is by using decimal format. Okay. Actually, it consists of two parts. Okay, network part and the host part. So in 32 bits IP address, we have to split them. Okay, so this side is network, this side is for a host. Okay, so it's similar to like a phone number. Yeah, the first 4 digits in Indonesia tells that you're part of a network, and after that, it's your host number. Okay. Yeah, so this is how the physical connection looks like. As I said, yeah, in the RFC 791. Okay, at the time they are using typewriter for creating a picture or yeah, a drawing. Yeah, so this is typical connection. Yeah, so you have a layer 2 segment here. Yeah, on the with the red colors, and then those layer 2 segment will be joined, will be connected through a layer 3. So layer 2, layer 3, layer 2, layer 3. So always like that. And then this is a physical connection or physical topology. And based on that, we develop the logical topology. So here we only focusing on layer 3 addressing. Okay. And then based on that, we develop the routing table so that when a packet arrives here on this interface, the router knows where to forward them. Okay, either to here or either to there. So for that purpose, a table needs to be created. Okay, where you want to go, and then on which gateway do I need to send the packet. Yeah, so this is a routing table. Yeah, so it works like a firewall. Yeah, so as you can see, when a packet arrives, okay, so it goes through here, and then yeah, better if you think in a binary format. So this one has to be converted into a binary format, and then this is the entry in the routing tables. Okay, so we check one by one. Yeah, so every entry here needs to be converted into binary as well. but I don't see the process because it's already computer. Yeah, computer always work in binary format. Sorry. Yeah, so checking, is it this one match? Is it this one? So it's checking the first 32-bit is similar to this entry or not. If not, and then go for the next one. The next one is /26. It means that it's checking the first 26-bit of the packet. Okay, so can you imagine that if we have 100,000 packets coming in the router, so you can imagine how busy is the router for looking at the routing tables. Yeah. So, and if no matching, and then we send to the default gateway. So as you can see, default gateway is the last priority of the routing tables. Okay. Any questions so far? Okay. So here in the MikroTik, okay. Actually, the picture is wrong. So routing decision, routing table reading is located here. So not here, not here. Okay, so needs to be shifted to the left. Okay. Any questions so far? No? Yeah, so this is administrative distance. The way we check, we pick the um, routing entry that we are using. Okay. Administrative distance, yeah, and then based on that, so we already discussed the addressing, yeah. So the first function for IP, Internet Protocol, is for addressing. Okay, after we get the addressing, okay, like this, so we have addressing for this, addressing for this, addressing for this network, and then the next step we need to use is routing. Yeah. So previously, the way we do is by using um, a class. Okay. So in the beginning, we have a class A, B, and C, but now we don't have it because right now we are using VLSM, yeah, variable length subnet mask. So there is no class A, class B, class C. Yeah, so we are based on that, we are doing CIDR, CIDR. So yeah, there is no class A, class B, class C. So we have to specifically state it here. Okay. So this is /17, and then this is the gateway. This is a slash whatever, and then here's the gateway. Okay. So that is the CIDR. Okay. We know that router is the device, routing is the process. Okay. So when we develop the routing table here, so again, yeah, every router must have routing table, okay, like this. Okay, and then this routing table has the way it works is by administering, okay, the destination address and then the gateway, destination address and then the gateway. So you have to log into every router and then you create this kind of entries. That's why it's called static routing. So you go to every router and then create them manually. Yeah. So it's called static routing. Well, to some extent it works, okay, for small network, but for big network, better we use dynamic routing. So the router will talk to each other and then develop their own routing entries. Okay. Again, if you have questions, please say something. Okay. Yeah, we have done the routing part. So information to note, important to note that path for incoming and outgoing can be different. Yeah, so routing is done only for one way, either outgoing or incoming. Okay, and then the thing that we can control, yeah. So for example, router one only can control outgoing. Okay, router one cannot control incoming because incoming is the responsible for router 3 and router 2. Okay, so we can expect if we send packet through this link, we hope, you can hope, but it's not always guarantee you get what you hope. Okay. You send over link number 1, and then you expect that the incoming also through link number 1. Okay, so that was it. Yeah, as I said, we need to have addressing, and then every addressing is identified with AS number. Okay, so this is how you develop this is how we develop the internet. Okay, so first we have to contact the IANA or IIR, saying that okay, I want to be in the internet. Okay, you have to pay this amount of money with the /4/24 or 23, and then you can connect to the internet. Okay, so this is your network. Yeah, and then in your network you have 2 border gateway, and then you exchange your prefix with them. Okay, that's how internet works. Yeah, so this is again still talking about routing. So we have interior routing, exterior routing, for example this one. So inside your own network, we call it intra AS routing. So for example, you can use OSPF, RIP, or ASIS. For exterior, to connect to other network, we can use EGP. Exterior, for example, BGP. So EGP is not routing protocol. It's just saying that, okay, it's a family of protocol, a group of protocol to talk to exterior. And currently, we just only have one. Yeah. One protocol for EGP. Okay, for IGP, we have many selection of protocols like OSPF, RIP, and then EIGRP. Yeah, and yeah. Okay, anything else? Yeah, multiple routing protocol. Yeah, it's possible. Yeah, so in one router, we can develop, we can run more than one routing protocols. Okay, so for troubleshooting, yeah, we can use some techniques here. We start from the lowest layer. Okay, so yeah, as I said, for encapsulation, we start from top down. But for troubleshooting, we start from the lowest layer to make sure that everything from the lowest layer is okay. Yeah, so if we have problem with the layer 3, for example, you cannot reach a certain IP address. So make sure that layer 1 and 2 are okay. Yeah, to make sure that, okay. Is the cable okay? And then sometimes, yeah, the cable is okay. Yeah, but there is a high high signal, especially if you are using fiber optics. Yeah, So there is a certain signal, fiber optic signal. If it is too low, and then the packets often drop. If it is too high, same thing. Okay, so it has to be in the level that is acceptable. Okay, so both are okay. I can ping, yes, but there are lots of packets missing or deleted. Okay, or drop. Yeah, so one way is caused by the signal. Okay. So first test is reachability to check whether you can reach an IP address or not. Okay, but it doesn't display how you reach the destination. So that's why we have the second here analysis for trace route. So actually troubleshooting layer 3 is very simple. Only two tools which are ping and trace route. Okay. Any questions so far? Well, at least yeah, we already informed that, okay, this is how the internet protocol looks like. Okay, this is how internet protocol works. Yeah. No questions? Yeah. Okay. Looks okay then. Yeah, maybe I can share one example here of of ping and trace routes. So how can we how can we interpret the results? Okay, so perhaps I can share another screen here. Okay, so this is my terminal. Yeah, usually when people are screaming, okay, on your ISP, usually you do ping test, right? Yeah, so you ping. Usually people are using Google services much, yeah. So usually our favorite is Google 8888. Okay, so if we see there is a reply, and then we are very happy, so it means that there is no reason you cannot reach the Google here. Yeah, so it's reachable. What is N? Because I don't have to resolve the DNS, but it doesn't display how do I get um, to the Google. Okay, so that's why we use a trace route. Okay, trace route, and then here it is. Okay, it shows us. Okay, so if I go to 8888, and then here's the first router. Okay, and then here's the second router, and then here's the third router. So it displays how many hops, we can say, how many hops do we need to reach the destination. Well, some router they don't reply to our request, to our ICMP request. So as you can see on hop number 7 here, we don't know the IP address. Yeah, but we know that, oh, okay, so this one is here, this one is there. And then we can check, oh, okay, so from which IP address is that? So we just copy the IP address, for example, here, 180.240. And then we check in the, we check them here. Yeah, the IP address. Okay, so one router from my place to the destination 888 is this one, 180.240. Okay, and so on and so forth. And then it can say here So the IP address here is part of this subnet. And then it shows, oh, okay, so this is /24 range. Okay, blah, blah, blah. Let's take one, 69. One of them is 69, where is 69? Oh, okay, here it is. Click. And then we can see, oh, it's from Singapore. It's located in Singapore. So the ASN is 7713. The owner is PT Telecommunication Indonesia or Telkom. And as you can see here. So we can also check, yeah. So I'm part, usually I will be part of this ISP. So Telkom Indonesia is one ISP, and then we can check here how many net blocks that they have. Okay, so as you can see, yeah, they have /24. See, /19. Oh, okay, no, it's not. Yeah, hosted domain, and so on and so forth. Okay. Yeah, but there is a possibility we can see how many IP address that they have. Okay, because Telkom is big, usually they have a big IP range for that. Okay, so I think that's all. Thank you very much. So hopefully you can at least you know how it looks like. Okay. Oh, the last one here. Perhaps I can show you the yeah, an example of how it looks like the internet protocol. So as you can see, this is one example of a Wireshark. Okay, so I capture some traffic here in my router, and then we can see. Okay, so for example, this is the frame. So I'm capturing frame. See, frame inside the frame we have IP, and then we have segment here. Okay, so as you can see, this is the version, and then enter header length. Okay, so perhaps yeah, we can check here. We can compare, or perhaps I can share the whole screen. Yeah. Okay, so we can see it's the way it is created. So first is the version. So we can see this is the version, yeah. So 4 bits. So this one here, and then we have internet header length. Yeah, internet header length here. Okay, so this one, yeah, and then we have the SCP. Yeah, see, different service field, differentiated service field. Call it DSCP. Okay, so this one here, and then we have a total length. This one here. So as you can see, the way they provide here in 1981 is still being used up to now. See, identification is this one. Okay. And then do not fragment is flags. Okay. And then fragment offset 0 means no fragmentation. And then time to leave 64 here. Protocol, so it knows that the protocol of upper layer is TCP here. Okay, checksum. Yeah, checksum over here. Source and destination address is over here. Is there any options? No, there is no option. So at this moment here, no options. Okay. Yeah, so this is one example of SIP. So as you can see, 5060 destination port is this one. All right. Oh yeah, perhaps I can also, because previously we need to planning our IP address, right? So perhaps you can use a software like this. Okay, so for example, we can say we have a /24 network, and then we can we can say, okay, .1 is for this one, or you can add a subnet, nested subnet, for example, to become /29. Okay, /29 for customer one. Oh, it's overlap. Yeah, okay. So because it's already done. Yeah. Or maybe we can use others. /21 for this one. Oh, yeah. Oh, okay. We need to change. Perhaps this one. Okay, nested subnet. Perhaps. /29. Yeah, it works. Okay, so this is the first address, and then we can add another nested subnet for point-to-point. So it means that /30. So TTP to customer one. It's done /30, and then we can see in here. Yeah. Okay. Yeah. So this is /30. So okay. So we have subnet, and inside the subnet we have another subnet. Yeah. Okay. So I think that's all. Can you see? Oh, yeah. Yes. You still see my screen, right? Well, I think that's all. It's time to say goodbye. Yeah. Where's the slide? Oh, okay, here it is. Yeah, thank you very much for coming. Yeah, we have done today. So if you're interested, please come to our training. If you, for those who needs the um, slides or recordings, all of them will be available in the information in the slide here. Okay, so slide will be available on Slideshare. A recording will be available on YouTube. Okay. Yeah, we have reached our session here. So please turn on your camera so that we can take some pictures. Okay, I will count 1, 2, 3. Okay, 1, 2, 3. Oh, okay, forgot the thumbs. Thumbs up. Okay, guys, show off your handsome face here. Turn on your camera. Okay, I will count 1, 2, 3. Yeah, 1, 2, and 3. Okay, guys, thank you very much for coming, and then see you in the next webinar. Have a nice day and keep safe. Hopefully see you in the next webinar.
Thank you. Bye.
Have a nice day.